Hi, my name's Dave Runyon, and since 1987, I've been involved in the environmental field, mainly with indoor air quality, and predominantly dealing with asbestos. Since the mid-1980s, we have dealt with literally hundreds of buildings throughout the U.S. that contained asbestos, conducting inspections, testing building materials, air quality testing, asbestos abatement management, and asbestos awareness training. This asbestos awareness presentation is to help educate you about asbestos and asbestos-containing materials. It will also show you how to work safely around the material if you work in a building that contains asbestos. What is asbestos? Simply put, asbestos is a mineral. Let's take a look at the definition of asbestos. Asbestos is a fire-retardant fibrous mineral used in the production of many different products, ranging from electrical insulation to roof tiling. Asbestos was widely used in the 1930s and up until the 1980s, but its use curtailed in the 70s and 80s due to the side effects. However, it still finds its way into some products today. It is a natural occurring mineral that is found in the ground and is mined. Asbestos normally runs in veins throughout the ground. Asbestos fibers are naturally in rock-type form and are mined in a very similar manner as you would mine coal or other such minerals. Now let's take a look at the characteristics of asbestos. Asbestos has many very unique characteristics that made it very useful in many industrial products as well as many building materials. It is resistant to heat and chemicals. It is a non-conductor of electricity. It is very strong. It is flexible, and it's cheap. Now let's take a look at its history. Asbestos was used in Cyprus 5,000 years ago. There was evidence of use in Finland around 2000 BC. Asbestos was well known to the Greeks and Romans. In the 1st century AD, Pliny the Elder noted that slaves working in the asbestos mines died at young ages. In the Middle Ages, suits of armor were insulated with asbestos. And in the 13th century, Marco Polo noted that he saw cloth that resisted fire. So what actual products used asbestos? Because of its characteristics, asbestos has been used in thousands of products over the years. Some of these include pipe insulation, tank insulation, other thermal system insulations, brake linings for both automobiles and industrial equipment, roof shingles, tiles, siding materials, wall panels, things such as that. Asbestos was also very commonly used as a binder in floor tile, mastic, linoleum floor covering, and tar papers, as well as ceiling tiles and ceiling panels. Spray-on or trowel-applied plaster, acoustic materials, and fireproofing were also very common products that contained asbestos. There are over 3,000 different products that contain or have contained asbestos over the years. Now that we know a little bit about where it was used, let's look at the types of asbestos. There are actually 6 different types of asbestos. The most common type of asbestos is called chrysotile, which is sometimes called white asbestos due to its color. About 90% of the asbestos found in buildings is chrysotile. The next most common type of asbestos is amosite or brown asbestos. Amosite is most commonly found in fireproofing or other higher heat applications. The third most common type of asbestos is chrysotile, or sometimes called blue asbestos. Chrysotile is not used that often, but sometimes it's found in some industrial applications where extremely high heat is an issue. The other 3 types of asbestos are anthophyllite, actinolite, and tremolite. These are rarely used but sometimes appear as contaminants in other asbestos-containing materials. The reason that asbestos is regulated in building materials is solely due to the health effects of asbestos exposure. There are 3 incurable diseases commonly associated with asbestos. These are asbestosis, which is a fibrotic scarring of the lung cancer, and mesothelioma. Asbestos fibers are very small. and can penetrate the body's natural defense systems and penetrate deep into the respiratory system. The picture on the left are normal air sacs. As you can see in the picture on the right, the walls of the air sacs are scarred. When asbestos fibers reach your lungs, the body tries to isolate them by building scar tissue around the fibers. This scar tissue is not flexible, and the lungs will not expand and contract, therefore limiting your breathing capacity. This is a normal effect from asbestosis. As you can see in this X-ray, the white area is scar tissue in the lung. This is a post-mortem X-ray of a man that died from asbestosis. Mesothelioma, on the other hand, attacks the lining between the chest cavity and the lung. Smoking impairs the respiratory system's natural defenses, which allows more contaminants to enter the lungs. It takes a long time between the exposure to an asbestos-containing material, or an asbestos fiber, and the onset of asbestos-related diseases. This is called the latency period. Latency periods for asbestos-related diseases are between 10 and 40 years. Now let's look at how asbestos is identified. Samples are taken of suspected asbestos-containing materials, and these samples are sent to accredited laboratories for analysis of any asbestos content. Several things can damage asbestos-containing materials. These can be physical damage, due to the material being maybe bumped or even just contact from everyday activities or maintenance and custodial work. Water damage is also a common problem due to leaks or condensation. Air erosion is another problem that can sometimes occur, especially around vents or other areas with a high airflow. If the material is in too bad of a condition to be repaired, then it must be removed or replaced with a non-asbestos containing material. How is asbestos removed? First, this must be performed by a licensed asbestos abatement contractor. The area around the material is put under what is called a containment. The area is enclosed with a 6 mil thick plastic. All critical barriers such as doors, windows, vents, etc. are also sealed with an additional layer of plastic. Some states and local areas have additional requirements for preparing an asbestos work area, depending upon local regulations, which can go above and beyond the federal requirements. At the entrance to the work area where the ACM is to be removed, a decontamination area is constructed. This allows the workers to remove their protective clothing and personal protective equipment, such as respirators, then to shower off to prevent the contamination from leaving the work area. Water from the shower is even filtered through a special HEPA filter. After the work area is sealed, it's placed under negative pressure, which creates sort of a vacuum in the work area. This means that if a breach in the plastic containment was to occur, then the air would be pulled from the outside into the work area, instead of the contaminated air inside leaking out. This is done with a special device sometimes called a negative air machine. This is a large blower device that is specially filtered with a HEPA filter, which filters the air to an efficiency of 99.97%. HEPA stands for High Efficiency Particulate Air. Asbestos-containing materials are removed using wet methods. The material is kept wet to reduce fiber release. Then, it's double bagged in 6 mil thick plastic bags that are specially labeled, identifying them as asbestos-containing materials. This material is then disposed of in an approved landfill. You can't just throw away asbestos anywhere. After the asbestos-containing materials are removed, the area is thoroughly cleaned using wet cleaning methods, then normally sealed with what's called an encapsulant. After the area is finished, final clearance air samples are taken inside of the work area. This is to assure the area is clean before the plastic containment is removed. There are two types of sampling and analysis that can be conducted for asbestos air samples. Under a HERA, if the quantity of asbestos-containing materials being removed is less than 160 square feet or 260 lineal feet, then the final clearance air samples can be secured and analyzed by what's called phase contrast microscopy. or PCM. PCM analysis counts a concentration of fibers and can sometimes even be done on site. This gives us a faster turnaround time on the results. This picture is of fibers as seen under a PCM microscope. PCM air sample results are measured in fibers per cubic centimeter of air. The wooden block you see in this picture represents 1 cubic centimeter. You can compare it to the quarter and get an idea of the size of 1 cubic centimeter. The other type of analysis is called transmission electron microscopy, or TEM. TEM is a very accurate asbestos-specific analysis, and it's conducted with an electron microscope. These must be sent off to the laboratory. However, the analysis is very accurate. This is a picture of asbestos fibers as it's seen under an electron microscope. When clearance samples pass, the containment can then be removed and the area can be reopened. Very important, keep in mind that asbestos being in your building does not in itself mean there's a hazard. It is, however, very important to keep any asbestos-containing materials in good condition. Also, if any outside contractors or workers are in your building, they should know the location of any asbestos-containing materials so they don't disturb it accidentally. Now let's take a look at some examples of what not to do if you work around asbestos-containing materials. If your room or office has asbestos in your wall plaster, do not drive nails into the wall. For example, if you need to hang pictures or something like that, use an adhesive-type hanger. If your floors are floor tile or linoleum that contain asbestos, do not use an abrasive pad to buff the floor. Also, do not cut, grind, or nail into the floor material. If you have pipe insulation running through your room, be careful not to puncture it or bump it with chairs or other objects. Special care should be taken if you need to remove a light cover to replace bulbs or clean them. There may be asbestos-containing materials above the ceiling, so you should always check before you do any activity such as that. Mainly, just use common sense and be aware that the asbestos could be there. If in doubt, always ask before you do anything that might disturb a possible asbestos-containing material. We can work safely in buildings containing asbestos as long as we respect it and do not disturb it. We hope this presentation has been educational and informative to you. Remember, you can work safely with asbestos in your building. Thanks.